everyone, it's Olivia here for Olivia's Online Tuition, and today we're going to be going through the Edexcel Higher Maths Paper 2 from June 2022. All the questions are timestamped in the description if you want to kind of jump around a little bit, just see a question that's troubling you, and if you want to know what topic a certain question is, that will also be in the description. Yeah, on we go. Question 1a, simplify x cubed all to the power of 5. Now that is a rules of indices question. If you have a power of a power, so this 3 is to the power of 5, you times them together. It's going to be x to the power of 15. There we are. Part B, expand and simplify 4 lots of x plus 3 plus 7 lots of 4 minus 2x. Let's expand first. So 4 times x, 4x. 4 times 3 is 12, 7 times 4 is 28, and 7 times minus 2x is minus 14x. If I group them together, 4x minus 14x, that's minus 10x. Then 12 plus 28 is plus 40. Then part C, factorise fully 15x cubed plus 3x squared y. So let's check the numbers first. Is there any number that is in common in both of these terms? And yes, there is. 3 is a factor of both of those numbers. And then we also can pull out x squared from both of those terms. The reason why is because 15, this first term, this one with 15 in it, is 15 technically times x times x times x, so it contains 3 x's, plus 3 times x times x times y. So both of them do have 2 x's in. So we can pull 2 x's out here in the form of x squared. And then what do I need to times 3x squared by to get 15x cubed? Well, 3 times 5 makes 15, and x squared times x makes x cubed. And then plus 3x squared to get 3x squared y, that just needs an extra y. And then put that on the answer line. That is then the end of question 1. And there we are, on we go. Question 2, describe fully the single transformation that maps shape S onto shape T. So what are options? We have translation, which is just moving it around, rotation, which obviously is rotating, something like rotating this around, right? Rotation, we have reflection, which is flipping it in a line, or we also have enlargement, making it bigger or smaller as well. Remember, enlargement, it kind of goes both ways. So which one is this then? So this shape S looks like it's been kind of slided up, slided across. So it's been just moved rather than reflected or rotated or anything like that. Because if it was rotated, it would kind of be a different kind of orientation here. So it's just been picked up and dragged, right? So that is a translation. And then remember how we describe translations with a vector. And the vector always goes across first and then up or down after. Looks like that. So across, left or right up here, right positive, left negative, and then up or down at the bottom, up positive, down negative. So I kind of get rid of these arrows and put my numbers in. We pick a point, we use that point there versus that point there. Pick the same point on both shapes, could be that one and that one, or that one and that one, or that one and that one. Doesn't matter, as long as it's the same point, as long as it's consistent. Doesn't matter which one you pick, but the same for all of them. So where are we going first? We'll do left and right first. So it's going left, 1, 2, 3, 4, 5. Left is negative, remember, so that's minus 5. And then it's going up, 1, 2, 3, 4, 5, 6. Up positive, which is positive 6. So therefore, translation of minus 5, 6. There we are, on to question 3. Question 3, the length of a football pitch is 90 metres, correct to the nearest metre. Complete the error interval for the length of the football pitch. And my error interval kind of like bounds, so I always put my number that I've got in the middle and then add and subtract whatever they're telling me they're rounding it to. So they've rounded it to the nearest metre, so I'm going to add a metre and take off a metre. So if I add a metre, that's going to get me 91. If I take off a metre, I'm going to have 89. And then to find the error interval, I need to find the midpoints of both of these. So I'm going to get 89.5 and 90.5. So then that one goes there, 89.5. This one goes up here, 90.5. Easy peasy. Yeah, and the reason this works is because this would round to 90 meters. Even if it was this, anything lower than this would round to 89. And this can't technically round to 90 because it would round to 91, but anything up to it would. So 90.49 recurring, which we don't like using in math. We don't like using recurring decimals, hence why we kind of call it this, but just don't put the line there. So it can't be this, but it can be anything up to it, hence why we put it. There we are. And that, easy, is question 3. On we go. Question 4. Festival A will be in a rectangular field with an area of 80,000 meters squared. The greatest number of people allowed to attend Festival A is 425. Festival B will be in a rectangular field 700 by 2,000 meters. The greatest number of people allowed to attend Festival B is 6,750. The area per person allowed for Festival B is greater than the area per person allowed for Festival A. How much greater? Okie dokie then. So, key point here is area per person. So we're kind of splitting up the area into individual people. Imagine they all have kind of like a little ring around them, a little box around them, essentially. So if we kind of write that out, for Festival A, let's put A there. So if we have the area, which is 80,000, that is for 425 people. But I want to know then how much area one person gets. 1. Therefore, I'm going to divide it by 425 to get from there to there. So I'm going to do the same on the other side. Divide it by 425. To get my calculator, 80,000 divided by 425, and I get 188.24 meters squared per person. And there we are. And then Festival B will be in a rectangular field 700 by 2,000. So what area will that have? Let's work it out. So area of a rectangle is length times width. So that's going to be just 700 times 2,000, which is going to be 14, because 7 times 2 with all these zeros. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If we do the same thing, so 100 and what is that? 1,400,000. Yep, is equal to then 6,750 people. So if I want them one person, I'm going to divide it by 6,750 on this side and 6,750 on this side. So if I do that, 1, 4, 1, 2, 3, 4, 5 zeros, divided by 6,750, and I get 207.4. And then I want to know how much greater this area is than this one. So I'm going to take them away. So 207.4, take away 188.24. And what do I get? Take away 188.24, and I get 19.2, which then rounded correct to the nearest whole number is 19 meters squared. Okay, and then part B, Callum is saying something, so I'll shuffle it down, see what Callum's saying. So Callum says 300 centimeters squared is the same as 3 meters squared because there are 100 centimeters in 1 meter, so you divide by 100. Callum's method is wrong. Explain why. So, because technically 300 centimeters squared is 300 by 300, right, in an area. So 300 by 300 to make a little kind of box, which if I kind of draw it in a nice orientation, or I do it like that, we have this box here, 300 divided by 300. However, if we then want to make that into meters squared, what we need to do is not only divide this side by 100, but also this side by 100. So you'd have to divide by 100 twice, or 100 squared. So Callum is wrong, as you would need to divide by 100 squared instead. And there we are. And that would be 5 marks for question 4. On we go. Question 5, the points L, M and N are such that L, M, N is a straight line. The coordinates of L are -3, 1. The coordinates of M are 4, 9. Given that LM to MN is 2 to 3, find the coordinates of N. Okay, let's draw this out. I need a diagram for this, I think. So if we have this guy down here being L, and then LM to MN is 2 to 3, which means that MN is bigger than LM, right? So if I have N over here, N is going to be closer to L than it is to N, because this one is smaller here. So I'm going to put M about there, maybe, right? Maybe it's a bit off, maybe it should be slightly further, but there we are. So the coordinates of L are -3, 1. Let's put that down. -3, 1. The coordinates of M are 4, 9. Let's put that on as well. Given that's that, so that is 2 to 3. Find the coordinates of N. Okay, dokie. Right, so let's have a look at what that is. That's what's striking out to me, because we kind of have two rectangles, right? Like that to that. And this rectangle is going to be kind of 1.5 times smaller than this one because of the ratio 2 to 3. That to that is times by 1.5. Oopsie. By 1.5. So this triangle, this length and this length, will be 1.5 times smaller than this triangle, this length and this length, right? Let's figure out what these lengths are. So if we look at the x coordinates comparatively, -3 to 4, we have to add 3 to get to 0, then 4 makes 7. Use a different colour actually. So that's then 7 along the bottom there. So then 7 times 1.5 to scale it up to the bigger rectangle, bigger triangle. 7 times 1.5 is 10.5. So that's going to be that one, 10.5. And then doing the same thing up here, going from 1 to 9. So this up here is 8, this little kind of line there behind where I put the M. So if I times that by 1.5, which is just going to be 12, isn't it? But I'm just going to double check it is indeed. That is then 12. So then, if we go from M and add on our coordinates, add on 10.5 on the bottom and 12 at the top, we're going to have 4 plus 10.5 to get, if I'm colour pen, 14.5. And then we're going to have 9 plus 12, which is then going to be 21. And there we are. And that is 4 marks. Cool, not the easiest question, a bit of a weird one. We don't really normally see this on this kind of on the GCSE paper. We haven't seen one like this probably ever, I don't think. It's quite an oddball question that they've kind of put together there. But yeah, how'd you do? Let me know. There we are. On we go. Moving on. Question 6. A new fern costs £679. The value of the fern decreases at a rate of 4% per year. Work out the value of the fern at the end of 3 years. This is a depreciation question, which is like compound interest, just a bit different. It's going the other way, essentially. So if we start in the way that compound interest normally starts, we'll have 679 here, times by a multiplier, which we're going to find, equals the value end of 3 years. So with this multiplier, exactly the same as compound interest. You start with 100%, because that's how much of the original we have. We have 100% of the original, because that's the original. And then every year, they're taking away 4%. So at the end of each year, the fern's going to be worth 96%, 96% of what it was worth the year before, right? So what you could do from here is find 96% of it, and then kind of keep whittling it down. Or you can divide this by 100, make it into a multiplier, and get 0.96. And then you can either, again, do that 3 times if you want, kind of feeding this value here into the start of each equation, timesing it all by the same thing, doing that 3 times. Or you can raise it to the power of 3, because that's the number of years it's depreciating by. That's always the case. The power is always the number of years, like in compound interest. And then, if we times all that together, 679 times 0.96 to the power of 3, we get £600.74. 2 decimal places, because money is always the 2 decimal places, because we have pounds and pence. And there we are, so £600.74. And there we are, and that would be 3 marks. On we go. Question 7. In Spain, Sam pays €27 for 18 litres of petrol. In Wales, Leo pays £40.80 for 8 gallons of the same type of petrol. €1 is 85 pence and 4.5 litres is a gallon. Sam thinks that petrol is cheaper in Spain than in Wales. Is Sam correct? You must show how you get your answer. So, with questions like this, where there's a bunch of kind of unit conversions, we want to be comparing apples with apples, right? So we need to be able to get the units in the same format. So euros into pounds, litres into gallons. I'm picking on Spain because Spain's first in the question. So I'm going to convert both of Spain's units. Okay, so we know that if I do the euros first, €1 is 85p. So 0.85. Oop, that's what I needed it. 0.85. We know then that he has €27 for his 8 litres of petrol. So the conversion is 1 to 27. That's times by 27. We can do the same on the other side, kind of like proportion questions. So I'm going to do 0.85 times 27, which is £22.95. Okay, so that's the euros. Let's do the litres. So we know that 4.5 litres, I should say, 4.5 litres is 1 gallon. And I want to know what it is for 18 litres. So what I'm going to do is maybe get it to 1 litre first. Might be a bit easier. So that there is divided by 4.5. So I'm also going to divide this one by 4.5. So I might as well. So 1 divided by 4.5 is 0.2 recurring. Gross. Let's just leave it as 2/9 for now, I guess. 2/9 of a gallon. Okay, and then to get from there to there, I'm going to times that by 18. So I'm also going to then times this by 18. So times 18, and I get 4. Perfect. So then that is 4 gallons. Okay, so now I know that in Spain we have €27, so actually we have £22, I should say, 95, being 4 gallons of petrol. In Wales, with Leo, we know that £40.80 is 8 gallons. Okay, so this is double this. Let's just double all this, figure out what it is for 8 gallons in Spain. So if I double £22.95 times 2, we get £45.90. So therefore, obviously, comparing 8 gallons with 8 gallons and pounds with pounds, we know that Wales is cheaper. So therefore, the answer would be Wales. So Sam is wrong. Unfortunately, Sam, sorry to say, but Sam is wrong. Put that down there. So Sam is wrong. There we are. Perfect. And there we are. There we are. So if your working looks different to mine, that is fine. And there is a million different ways to do this question. You could have converted both of these or converted like 1 unit a piece. Essentially, you converted the euros in this one and the gallons in this one. A million different ways to do it, right? As long as you get roughly the right roughly the right answer, as long as you know that Wales is the best price, then chances are your method is probably going to be fine. If you want to double check it, feel free to, if you want to try and type it in the comments, then have a go, I guess. Or show your teacher or a friend, and they'll be able to probably confirm it for you. But there we are. On we go then. That was question 7. On we go to question 8. Question 8, use your calculator to work out that there. Give your answer correct to 3 significant figures. So I'll talk you through how you type it in, because this shouldn't really be a question that you get wrong, as long as you're careful with what you type in your calculator. So fraction button goes first, because everything then populates like the fraction button. And then on top, we need the cube root button, which is shift and then square root. And then 1.57 power of 4, which is the power of 4 button, is the X with a little box above it, like that. It'll probably be like underneath your like quad, or it'll be next to where it says log. Either or. And then plus tan 60, close bracket, downward arrow, 7.2, power button, fraction button, 1/2. equals. So your calculator should look exactly as it does here. If it doesn't, if you've got the fraction in the wrong place, or the root over the wrong things, or the power in the wrong place, then correct it. Make sure it's good. Because it really, if you get the question wrong, you'll be one of the few that gets it wrong. So be careful. So then the answer is, if you write it out in kind of in full first, 0.73933799403. My calculator's telling me. And then round it to 3 significant figures. Third sig fig is this one here. Will it round up or will it stay the same? There's a 3 after it, therefore it will stay the same. So then it is 0.739. And there we are. That is the answer. Cool. On we go then to question 9. Question 9. A box in the shape of a cuboid is placed on a horizontal floor. The box exerts a force of 180 newtons on the floor. The box exerts a pressure of 187.5 newtons per meter squared on the floor. The face in contact with the floor is a rectangle of length 1.2 meters and width x meters. Work out the value of x. Okay, so they're giving us this equation, so let's put in what we know. So we know that pressure is force divided by area. You know that the pressure is this one here, there it is. The pressure is 187.5 equal to the force, which is 180 divided by the area. That's what we're obviously then trying to find. So let's find that. If we then rearrange this, area is in kind of an awkward spot down here. So I'm going to times up by area. So I'm going to then get 187.5 times area equals 180. Then we'll divide this down there to move it away from the area. So area then on its own is 180 divided by 187.5, which is then 180 divided by 187.5. 0.96. Okay, perfect. And then remember the area of a rectangle is length times width. So then we know that length times width is 0.96 in this case, gets the area. Now the length is 1.2 and we want to find the width, which they've called x. Let's call it x as well because we might as well. Equals 0.96. Then divide through by 1.2, x is equal to 0.96 divided by 0.12, oh no, not 1.12, 1.2, which is 0.8. There we are, and that is 3 marks. There we are, question 9. Oh my god. Question 10. The box plot shows information about the sales in thousands of pounds of an online store each month. Andrew says 3/4 of the given data lies between £160,000 and £350,000 because these are the values of the lower quartile and the upper quartile. Andrew is wrong. Explain why. Okay. So, essentially the reason why is because the lower quartile is a quarter of the way through the data, right? So we have a quarter from the lowest number to that lower quartile. So the quarter of the numbers there. And then up here, this is the upper quartile there. That is 3/4 of the way through the data. So there is again another quarter hanging out here after the lower quartile, okay? So 3/4 can't lie between there because it's essentially a full one. Take away the bit to either side. So take away 1/4, take away 1/4. If we then kind of deal with this, 1/4 minus 1/4 is minus 2/4, which is minus a half. So then we have 1 minus 2/4, which is 1 minus, simplify that, 1/2. 1 minus a half is a half. So Andrew is wrong. Explain why. Because half the data lies between the upper quartile and the lower quartile. Next part then, the table shows information about the sales in thousands of pounds in a shop each month. Part B, on the grid below, draw a box plot for this information. So remember, the box plot lines go at least lower, median, upper, and greatest. Isn't that convenient? In order already on the table. So we get my straight line to that. So least value is 30. These lines are 10 each because 10 of them get to 100. Therefore, there must be 10 each. So 0, 10, 20, 30 is then this guy there. Okay. Lower quartile is 80, which will be that one there. And then medians 170, which is 50, 60, 70. Upper quartile is 260. There we go. And then 350. Okay. And then kind of the height of these lines is kind of a purely kind of cosmetic choice, up to the person drawing it. I don't mind all mine being the same size like it is here. My lines are pretty much always like all the same size. But you can have these lines being smaller or these lines being bigger. Either or, that's all kind of like a cosmetic choice. Doesn't really matter. As long as your lines are in the right place and it's connected looking like this, then that's fine. On we go. In part C, compare the distribution of the sales of the online store with the distribution of the sales in the shop. Okay, so when we see that phrase, compare the distribution, we're always comparing two things. We're comparing a range, either the interquartile range or the actual range, like highest, or lowest, and that will tell us about the spread, how spread out the data is. Then also compare the median. Essentially, because the median will tell us the average, spend sales, so it tells us which one essentially sold more. That will tell us. So the who spent most, or who sold most, technically, in this context. Who made the most sales? So if we look at the range, which is either the interquartile or the upper, take the lower, either or. If you find that one of them's the same for both of them, check the other. Like say if you find the range and the range is the same for both of them, then find the interquartile range, because that might not be. My interquartile range is upper quartile minus lower quartile. So if you find the normal range, that's then 10, 20, 30, and that's 350. Therefore, the range on this one is 320. Then this one we have, 60 to 420. If we take those away, probably out of my head, but I don't really want to. 360. There we are. So let's put that down then. So the range for the online store is greater, so the sales were more spread out, something like that. The one that's higher, with higher range, has the most spread out data. What more spread out? Spread out. And then the median, whoever sold most. So the median for this one's 200, it's bang on the dot. This one is 160, 170. So the median for the online store is greater. So the online store had higher sales. So the online store had higher sales. And there we are. That would be 5 marks overall for question 10, 2 marks for this question. On we go. Question 11. Kieran has 13 workers he can use for a job. He knows that 6 workers would take 14.5 days to complete this job. Show that Kieran has enough workers to finish this job in less than 7 days. Okay, so if he has 6 workers and they take 14.5 days. So we can treat this like a proportion question. So that has 13 workers. How many days will that take? Well, how do we get from 6 to 13? What do we times by? And we do the opposite. Or actually what we could do is either that, which is kind of slightly shorter, or we could find 1 worker first, see how many days that would take him. So divide by 6 would get you that. But remember, this is inverse proportion, so it won't take less time. If it was 1 worker, it would take more, right? So instead of dividing, we're going to times instead. It's going to take more days. I think that makes a lot of sense, right? If we go from 6 workers to 1, it's going to take 6 times as many days for it to complete, right? So 14.5 times 6, which is 87 days on its own. 87 days. Okay. And then we don't want 1 worker, we want 13 workers. So that is times 30. So we're going to do the opposite of the side, it's inverse. If you're doing 13 more workers, it's going to take now less days. We divide by 13. Do 87 divided by 13, which is 6.7 days. And 6.7, you may already know, is less than 7. So it will take less than 7 days. And there we are, and that's question 11. Oh my god. Question 12, the equation of the line L1 is y equals 2x plus 3. The equation of the line L2 is 5y minus 10x plus 4 equals 0. Show that these two lines are parallel. If lines are parallel, that means that they have the same gradients. Okay, so we've got the gradients out then, don't we? So we need to get them both into the same format. This is the typical format, that's one that we like. The y equals mx plus c, so I'm going to get the L2 into that format. So I'm going to change L2 into y equals mx plus c formats. Okay, so we're starting with 5y minus 10x plus 4 equals 0. So I want y on its own, so I'm going to shuffle everything else. I'm going to shove it over there, right? So 5y is then going to equal, if we add 10x over there, 10x, and then we take 4 minus 4. And then we're going to divide through by 5 to get a y on its own over here. So then y is equal to 2x minus 4 fifths, adding both things by 5. And then if we compare the equations, L1 is y equals 2x plus 3. L2 is y equals 2x minus 4 fifths. So therefore, gradients are both 2. So the lines are parallel. There we are, and that is that. Question 13, enlarge the shaded shape by scale factor -2 with centre of enlargement 0, 0. So when you're doing enlargements from a point, the first thing that you do is find the vector of each of the points. So I'm going to do for the first one first, so this one here. So for the vector for this, and the vector we saw earlier in the other question is left, right first, and then up, down. So for point number 1, do it in black pen, that is going to be 1, 2, 3, 4, 5 left. So -5, let me just double check. I think I might count that. 1, 2, 3, 4, 5. Oh, I didn't. There we go. 5 left. And then after you get to there, you're going 2 down. 1, 2, which is then -2. And then for each of the points, I'm going to then times that by our scale factor. I'm going to times that by -2. To then, if I put that up here, give us our new vector, which is going to be -5 times -2, that's 10. -2 times -2, that is 4. That means our new point is going to be, if we count from here, using our new vector, it's going to be 10 right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, right is a positive number. Then 4 up, 1, 2, 3, 4. So that kind of black point there is now going to be there. And then if we kind of do that same thing, but for the other points, if I put this one in green, that's going to be 1, 2, 3 left. So -3, and then 2 down, -2, times that by -2. My face comes in the way. I'll put it over here. -3 times -2 is 6. -2 by -2 is 4. So then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. There it is. And then let's keep on going on. This one here, number 3, is 1, 2, 3, 4, 5, 6 along. So -6. And then 1, 2, 3, 4 down. Down, so therefore -4. And then times that by 2 to get -6 times -2, I should say, is 12. Not -12, positive 12. Then -4 times -2 is 8. So then I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 1, 2, 3, 4, 5, 6, 7, 8. There, and then might have to figure out where the other point goes, but if not, I'll do it one more time just to kind of show you it for the last time. So the purple point is then 1, 2 across, -2, and then 4 down, -4 times by -2 is then 4, 8. So then if I go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And there it is. And then if I go back to my original pen colour and join all those together, that one to that one, that one to that one, that one to that one, and that one to that one. And there we are. That is how you enlarge a shape with a negative scale factor about a point. And there we are. And we go then to question 14. Question 14, Saffron wants to work out an estimate for the total number of fish in a lake. On Friday, Saffron catches 180 fish from the lake. She puts a tag on each of these fish and puts them back into the lake. On Saturday, Saffron catches 305 fish from the same lake. She finds that 45 of the 305 fish are tagged. Work out an estimate for the total number of fish in the lake. So this is capture recapture, which has made quite a popular appearance in the past few years. It's come up in like every paper for the past like 2 years for some reason, every paper series, and then never before that. Odd. But anyway, so let's convert this sentence into a fraction. So she catches 180 fish out of how many? Who knows? Let's put that as an x. And then with capture recapture, we can assume that's going to be the same fraction as this one here. So on Saturday, Saffron catches 305 fish in the lake. 45 of the 305 are tagged. Okay, and then all we need is find x, and that will give us the 3 marks. Easy peasy. So if we cross multiply from here, that times that, and that times that, we get 180 times 305. 180 times 305, which is 54,900 is equal to 45 times x, so 45x. Then if we divide this number here by 45, we get x equals 1,220 fish. Oop, crossed it out. There we are. So 1, 2, 2, 0. And that is 3 marks. On we go. Question 15. The ratio of Marta's hourly pay to Khalid's hourly pay is 6:5. Both Marta and Khalid get an increase of £1.50 in their hourly pay. The ratio of Marta's hourly pay to Khalid's hourly pay after this increase is 13:11. Work out the hourly pay before the increase for Marta and Khalid. Okie dokie then. So, thinking about what ratios are. So before, Marta could have been earning £6 an hour and Khalid £5, right? Or £12 to £10, or 18 to 15, right? So we can always scale it up in that way. So either times it by 2, times it by 3, by 4, by 5, by 10, by 50, by 20, 100. Doesn't matter, 20, 100, by any number is what I'm trying to get at there. And that will be that, right? So we don't know what that multiplier is. So we know that the actual hourly pay are going to be this ratio, but times by whatever the multiplier is. Does that make sense? To get them to the actual number, whether it's 1 times this ratio, so it is what it is, or double it, or triple it, whatever it may be. This might have been simplified, right? And then what they've done is they've added £1.50. Okay, so we've then got 6x plus £1.50 to 5x plus £1.50. That is then equal to the ratio 13 to 11. Okay, hopefully we're making sense so far. Because they started with this as their base pay. They then have some multiple of that, some lot of it, then whatever lot they had of it, plus 1.50 to get their new increase, which is this 13 to 11 ratio here. And then a little kind of fact we can use. If we have a ratio equals a ratio, we can convert them into fractions, which is quite helpful. And convert them into fractions just gives us 6x plus £1.50 over 5x plus £1.50 equals 13 over 11. And then from here, I can cross multiply to have a fraction equals a fraction. So I'm going to times that up there. I'm going to times that up there. So I'm going to get 11 lots of 6x plus £1.50 equaling 13 lots of 5x plus £1.50. If I expand this, 11 times 6x, that's 66x, plus 11 times £1.50, which is 16.5, equals 13 times 5, which is 65x, plus 13 times £1.50, which is 19.5. And then I want to rearrange this. I'm going to move that over there to just give me x, if I just take it away. Equals then, if I move that over there, 19.5, I should say, minus 16.5, which is 3. So therefore, that x that we had in this ratio was 3. So they earned 3 lots of this ratio. So Marta earned 6 times 3, 18, and Khalid earned 5 times 3, 15. And there we are. And that is question 15. 4 marks. Oh my god. Question 16. A shop manager wants to advertise special offers on social media platforms. The manager asks 100 customers which of type A, type B, or type C they use. Of these customers, 4 use all 3 types, 16 do not use any of type A, type B, or type C, 8 use both A, B, but not C, 14 use B and C, 62 use A overall, and all 20 who use C use at least one of either type A or type B. Okay, complete the Venn diagram at full information. That's a lot of words all at once, right? Let's just go through them and put in what we can put in. So 4 use all 3 types. Okay, so 4 is going to go in that kind of section there. So let's then get rid of all that. 16, you don't use any. Okay, so that's going to be out there. Okay, which means that of the 100 customers, I've currently put 20 in. Therefore, there's 80 left. So I'm going to kind of put that there to remind myself. 8 use both type A and type B, but not type C. Okay, so A, use A and B, but not C, which means that 8's going to go there. Which means I am now left with 72. Okay. 14 use both type B and type C, however, haven't told us that they haven't used type A. So this 4 here is also included because everyone in there uses type B and type C. Does that make sense? Both of them. Because it hadn't told us to exclude A, which would include this circle here. So 14 minus the 4 that we've already got that use B and C, that is then 10, which then makes that 62. Okay, 62 in total use type A, but that could be here or here. We don't know, right? So we can't put that on yet because we don't know how many is in this section or this section, and we need one of them to figure out which one, how many is left over, right? So we can't do that one yet. And then last sentence, all 20 who use type C use at least one other of type A and type B. Okay, which means that none use just type C because everyone who uses type C also uses something else as well. So no one uses just C, therefore 0 goes in there. And then all 20 who use C. So there's 20 people in this C circle. We've already got 14, which means that 6 needs to go in there. I can get rid of that and get 56. No, that's not right. My gosh, my mental maths. Abysmal. Absolutely abysmal. Oh, what, 56? Oh, I need to trust myself more. 56. There we go. 56 left. That's that. If I can get rid of all that, we then know that 62 in total use type A. So how many is left after 62? So 62, take away 8, take away 4, take away 6. Pulled it in my head, but oh well. Means that 44 are left in there. So then take away 44 from 56. Forget how many is left to go in the Venn diagram. And then get 12, which means that the only section left for those 12 to go in is that one. Therefore, 12 must go in there. And then one of the customers is chosen at random. Given that this customer uses type A, find the probability that this customer also uses type B. So that is going to be these people here, right? Because 8 use B and A, but not C. And 4 use all 3 of them, right? So people that just use type A, that is, if I get rid of the line where I crossed it out, that is 62 on the bottom. So 62 use type A, and then that also use type B. So how many of those people also use type B? Well, that's that, because that's overlapping there. And these guys, so 8 plus 4, that is 12. And that then is our answer, 12 over 62. And that overall then is 6 marks. And there we are, on we go. Question 17, a solid cone is joined to a solid hemisphere to make the solid T shown below. Okay, the diameter of the base of the cone is 7, the diameter of the hemisphere is 7. Okay, the total volume of T is 120 pi, the total height of T is y. Calculate the value of y. Okie dokie then, so we've been told the total volume is 120, so we're going to use something like that, right? So let's find the volume of each of the bits, add them together, and that's going to be 120 pi. So the volume of the sphere, let's do that first, is 4/3 pi r cubed, which is then divided by 2, because we've only got half of it, we've got a hemisphere, so all that then divided by 2. The radius we've been told is 7, which means, oh, actually, oh, sorry, tell a lie. The radius is 3.5 because the diameter is 7. Silly me. So 4/3 times pi times 3.5 cubed all over 2. Good lord. If we then type that in our calculator, so 4/3 times 3.5 cubed. I'm going to leave the pi off from a calculator because I know it's going to have pi slapped over it anyway. It doesn't really matter. So then I'm going to get, good lord, 343 over 12 pi. Okay, goody goody. Right, so then we have volume of the cone next, which is 1/3 pi r squared h. Okay, so that is then going to be 1/3 times pi times 3.5 squared times whatever h is, which is then going to be 3.5 squared times 1/3. 49 over 12. Got some horrible numbers in there. 49 over 12 pi h. Okay, okay. Then we've been told the total volume, so this plus this, is 120 pi. So if I put that over here, we've then been told that 49 over 12 pi h plus 343 over 12 pi is then equal to 120 pi. What I'm going to do is divide by that, and by that, and by that. Don't want all those pi's. I'm also going to times it all by 12, I think. So I'm going to get then 49 h plus 343 is equal to 120 times 12, which is 1,440. Then I want h, so I'm going to take away 343. So, take away 343 is 1097. So 49h equals 1097 divided by 49. I get a rancid number, is 22.39. So that is then this here. So it's not the answer, that's not y, that's just this bit here. 39. I also need to add on this bit, but that's just a radius, remember, because that's going from the center downwards. So radius. So that is adding on 3.5. So I'm going to do 22.39 plus 3.5 to get me, does it want a certain number? Yes, 3 bigger figures to get me 25.9. And that is that. So that's your answer. I got slightly different to me, maybe, because of the way that things round, but it should be roughly there. And if it isn't there, then be careful with your rounding, because you would lose a method, like an answer mark at the end if it wasn't this exact number. So if you've got like 25.8 to 29 point or 26 exactly, then look at where you're rounding and be careful not to round too early. But that is that. And then the diameter of the base of the cone and the diameter of the hemisphere are both increased by the same amount. Assuming the total volume of T does not change, explain the effect this would have on your answer to part A. Okay, so let's have a look. So for part A, what did we have? I'm going to shuffle this down a little bit so I have more space. So we had 4/3 pi r cubed over 2 plus 49 over 12 pi no, we didn't. We had then a third pi r squared h equals volume total. So they're telling us that the diameter of the base, and that's just the radii, are increasing on the same amount. So that is increasing and that is increasing, right? But then they've told us that this is staying the same. So if both of these on this side are increasing, the height is going to have to decrease to balance out the increases on this side in order to keep it the same. If this went up, then this height went up, then t would also have to go up, because then everything decreasing on this side, therefore it would have to go up, right? So therefore h would have to decrease. H would decrease to make sure this kind of balances out to get this the same as they wanted it here. But there we are. And now question 17. On we go. Question 18. PQR and QRS are triangles. Obviously, calculate the length of QS. Give your answer correct to 3 significant figures. You must show all you're working. Okay, so we've got triangles. It's question 18. It's going to be the sine and the cosine rule, right? It's got to be. There's nothing else it could be. We're late in the paper, question 18. It's not early days. It's got to be the sine and the cosine rule. Just a case of which one and where, right? So what do we want? We want QS. Where's that? That's there. So let's put an X on it, because why not? Okay, so the first thing I saw is the sine rule, because I know that that is a half pair. So if I can find this other length over here, I would then have enough for the sine rule to find x, which would be rather convenient, which means that if I put this as y, I want to find this guy here. Which, if this is the sine rule, this one's then probably going to be the cosine rule. But if we didn't already know, then there's no full pairs in this triangle, this PRQ triangle, because this is a half pair. We only know one of them. Then that's a half pair, and that's a half pair. We don't know really any full pair, which is like a matching angle inside. So it must be the cosine rule. It must be. If there's not enough pairs, it's the cosine rule. Remember, the cosine rule is the big long fatty one. So a squared equals b squared plus c squared minus 2bc cos capital A. Let's label it all up then. There's only one angle in this equation, therefore 27 has to be capital A, because the capitals are the angles. There's only one of them, therefore it has to be this one. Which means that y has to be lowercase a, and then these guys can be b or c. Doesn't matter. It's like Pythagoras. Any order works fine. They've put that in then. So we have either a squared or y squared, as I've called it, is equal to 9.4 squared plus 11 squared minus 2 times 9.4 times 11 times cos of 27. And then if I type all that in, so then again I'm going to cut it out, so I'll be back in a second. I get y squared is 25.1 essentially, but don't round it on your actual calculator when you type in the square root of it. We want to use the calculator answer. So y is in the square root of the thing on your calculator, the square root answer, which is just 5. There we go. So y is then 5. Easy peasy. And then that's then 5. I want to do the sine rule then with these kind of pairs here. Now I have a full pair with 5 and 41 and a half pair with 88 and x. Therefore, sine rule. I'll put that over there. So then we have, try to find a side. So then sides go on top. A over sine A equals b over sine b. A can be the full pair, because why not? Because it was a before, might as well be a now. So then we have 5 over sine 41. Oops, that doesn't look like one, is it? 41 equals b, which is x, over sine b, which is sine 88. Okay, and then to get x on its own, I need to times up by sine 88. So I'm going to have 5 over sine 41 times sine 88 equals x. So then 5 over sine 41 times sine 88, and I get 7.62. And there we are. That is the answer. 7.62. So yeah, there we are. Nothing really much to say. It's kind of a classic sine cosine rule question. If you get triangles, it's question 18. There's going to be really nothing else it's going to be. It's got to be the sine and the cosine rule. If you have actually angles and lines on it, it's got to be the cosine rule or sine rule. And yeah, there you go. If you practice with those, Maths Junior have a really good section on them. Again, always plugging maths uni. But there we are. On we go for now. Question 19. Question 19, the functions g and h are such that g of x is equal to the cube root of 2x minus 5, hx is 1 over x. Find g of 16. And g of 16 is just, what have they done? They've put 16 where x is. So I am going to do the same. I'm going to put 16 where x is. So g of 16 is the cube root of 2. That's not 2, is it? 2 lots of what is now 16 minus 5. So I'm going to get let's type in my calculator, the cube roots, shift square root of 2 times 16, which is 32, minus 5, which is 3. And voila, easy as that. And then part B finds h of g minus 1 of x. So with these, you read it this way. So we're going to do inverse of g first, and then put that into h, always reading from right to left. So we find the inverse of g. So if I'm using inverse, make it equal to y first off, because that makes it a bit easier. So y is then equal to the cube root of 2x minus 5. And then get x on its own. So I'm going to cube y cubed equals 2x minus 5. I'm going to add 5. So y cubed plus 5 equals 2x. I'm then going to divide by 2. I should put this downwards. There we go. So y cubed plus 5 over 2 equals x. Then I'm going to replace y with x, swap them over again. So I'm going to get, let's have a look, x cubed plus 5 over 2. And that is then equal to g minus 1 of x. Okay. Then I need to put this into h, which is then 1 over all of that. X cubed plus 5 over 2. Gross. So I'm going to rewrite this. I don't want fraction in fraction. Fraction in fraction is a situation I wish to avoid at all costs. So I'm then going to change it to as 1 divided by x cubed plus 5 over 2. And then I'm going to keep flip change. So I'm going to do 1 over 1. That keeps flip 2 over x cubed plus 5, and I'm going to change to get that. You can't even see it. Of course you can't. There you go. And then that's going to give me 2 over x cubed plus 5. And that is your final answer. And there we are. And that is question, what was it? 19. There we are. On we go. Question 20. A, B, C and D are points on the circumference of a circle centre O. ADE and BCE are straight lines. Work out the sides of angle CDE. Give a reason for each stage of your working. So a lot of things are telling me that these are circle theorems I'm going to be using. This give a reason for each stage of your working. Circle theorems. There's a circle theorems. There's angles. There's like a kind of little quadrilateral guy going in here. There's an arrowhead going on. So that is all shouting circle theorems to me. So the arrowhead one is the one I'm going to do first. So remember, angles at the circumference are half angles in the center. So that is going to be half of 132, which is, if I wasn't being lazy, 66. And there we are. So I'm going to write all the stages. I'm going to do that at the end, so we'll read it all together at the end. But for now, I'm going to kind of continue working through with these angles. I recommend doing that. Unless you get stuck, then write them out, I guess. But while you're still kind of in the motion of the question, while you're kind of in the flow of it, just keep going with your circle theorems until you kind of get stuck and you want to kind of have a bit of a break, write the stuff down, then come back to it with a fresh mind. But while I'm in the mood and in the zone, I'm going to continue. So they do this quite a lot where they have B, C, D, O looking a bit like a quadrilateral, and we should know that opposite angles in a cyclic quadrilateral add to 180 degrees. However, this guy is not a cyclic quadrilateral. This is kind of like a red herring, and they do this a lot. They have it looks like they have something. I speak very quickly, don't I? They have something that looks very quadrilaterally, I guess quadrilaterally, if that's a word, but it isn't a cyclic quadrilateral because this point is not on the circumference. But that guy is. So this is your cyclic quadrilateral. That guy. That doesn't look very quadrilaterally, but it is. Because it doesn't look kind of like a square, which we kind of often associate with quadrilaterals, or a rectangle. It's too wonky for that, isn't it? But it is still a quadrilateral because it has 4 lines, 4 angles, and they're all touching the circumference. All those points. So there we are. So if I then use my rule, so opposite angles in a cyclic quadrilateral add up to 180. So therefore this one is 180 minus 66, which is 114. And there we are. That is that. Okay, dokie then. What next? Let's have a think. What are we trying to find? I should have pointed that out originally, shouldn't I? CDE. Where is that? CDE. That guy. That's what we're looking for. Okay, dokie. Right. Well, that is a straight line if ever I saw one. This BCE, does it tell me that's a straight line? It is. Perfect. That is a straight line. So therefore, this angle here is 180 minus 114, which is 66. And would you look at that? 66, 16, missing angle. Perfect. Angles in a triangle add to 180 degrees. So 180 minus 16 minus 66 is 98. Therefore, our missing angle CDE is 98 degrees. And there we are. So I'll take some time. I'll write out all the reasoning that you need to put. So back in a second once I've written all that out. Okay, then there we are. Also color coded it for you. Even easier of ease of reading, I guess. So the first thing I did was that angles at the circumference are half angles at the center. So this 132, half that to get the 66 up here. Second thing I did was opposite angles in a cyclic quadrilateral add to 180. So these two angles here, the one at A and the one at C, they add up to 180. So 180 minus 66 is 114. Step 3 is these are on a straight line. So 180 minus 66, so 180 minus 114 equals 166. And then number 4 is just angles in a triangle. 180 minus these two to get that one. And there we are. So we need all those 4 things to get 4 marks. Mark each. And there we are. Question 20. On we go. Question 21. The graph of y equals f of x is shown on the grid below. On the grid above, sketch the graph of y equals f of minus x. So with f of minus x, that means that all the x coordinates on this graph are changing their sign. So we kind of go through. 0 is going to stay as 0 because that doesn't have a sign to begin with, so it can't change it if it doesn't have one. And then if we look at this point here, it's minus 1, 1. So if the sign changes on the x, it's going to be 1, 1. There we are. And then this is the next kind of nice point. So that's going to be 1, 2, 3 left, and then 0. But that's going to be 1, 2, 3 right, and then 0. And then this one is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just reflecting it essentially in the y-axis. And then that one's 2 over there, so that one's going to be 2 over there. Changing it all around. And then if we connect all those lines up, and there we are. And that is what we get. Might be worth moving that slightly closer to that one, but there we are. That'll do for now. And then here is a sketch of the graph y equals tan x. The graph of y equals tan x is translated to give the graph of y equals g of x. Following the translation, the point Q shown on the graph above moves to point R. The point R has coordinates 90 minus 5. Find an expression for g of x in terms of x. So, how well do we know our tan graph? So we should know that it kind of goes up in 90s on the bottom. So that's 0. And then it asymptotes at 90. And then cuts at 180. Asymptotes at 270. Cuts again at 360. So what it's done is it's moved from Q here to 90 over here, as it says that it's done down here. So what has it done? It's moved 270 left. Okay, it started at 360, ended at 90, so it shuffles 270 degrees left. Okay, and then at this point here, Q is 360, 0, because it hasn't gone any up or down, it's on the x-axis. But it's gone to minus 5 with this new point R. So therefore it has gone 5 down. Okay. And then we want an expression for g of x in terms of x using this guy here. So think about how we're going to write this then. Very similar to our other transformation up here. So if we've got then y equals tan of x, right? What's going to happen to x? If we're moving 270 left, what we do is we put x plus 270. If you remember, inside the bracket lies, which you might have been told, I think it makes it a bit easier. In the bracket lies, therefore you do kind of the opposite. So if we're telling it to go right, it's going to go left, or kind of where the lie is in this case, because we're putting the equation together. But if we saw this, we'd expect us to be liars, therefore we go the other way, if that makes sense. Again, it doesn't really make a lot of sense because it's kind of why they're lying in the first place. I don't know, but it kind of makes it make more sense, essentially. So in this bracket, it always lies. That is the way that it works. And then moving 5 down out of the bracket doesn't lie. So we can just put minus 5 down in the way that we normally would for things like translations. And there we are. And that is that. Happy days. So if you want to do more questions like that, more practice ones, then let me know in the comments. I can make a video on it. Or there's loads of questions on Maths Genie as well. They have a big section on this, which is really rather handy. So I think it's in the grade 9 section, so feel free to have a look at that. But yeah, in the bracket lies, so you do the opposite, write it the opposite, do the opposite if you're seeing it written, and then out of the bracket for the y coordinates does not lie. And there we are. On we go then to the last question, question 22. Question 22, find algebraically the set of values of x for which x squared minus 49 is greater than 0 and 5x squared minus 31x minus 72 is greater than 0. Okie dokie then, so I'll do this one first. I'm going to factorise both of them, maybe use a formula for this one because it's a bit big for factorising, but see when I get there. So this I'm going to factorise over because that is x plus 7 and x minus 7. If I can see that, I just might shuffle it down a little bit. There we go. So that is in greater than 0, which then gives us our solutions of x equals minus 7 and x equals 7. Just flip them around, flip the signs, go from there. And remember, it's x plus 7, x minus 7 because it's the difference of two squares. It's x squared, take away another square number. And there we are. And then to figure out the inequality, whether it's x is less than minus 7 and x is greater than 7, or x is between minus 7 and 7, to figure that out, which one it is, we use the little graph sketch. If I draw out my little sketch of a graph like that, that's minus 7 and that's 7. And then we want for when the quadratic is bigger than 0, so we want when it's above ground, technically, which is that one there and that one there. Two bits of graph, therefore two separate inequalities. So we're going to have x is less than minus 7 and x is bigger than 7. Those two separate pieces. And then we have this inequality here. 5x squared minus 31x minus 72 is greater than 0. So you could factorise this, but you have a calculator. So I think because the numbers are so big and you can't really divide through it, I would just use a formula because it's a bit big to do factorising. Finding your factors of, what's that, 360, and which times make 360, add to make 31. Bit of a faff, right? Bit of a nuisance, I should say. So I'm going to use the formula, I think. So x1 and 2 is minus b plus or minus square root of b squared minus 4ac all over 2a, which is then minus minus plus or minus square root of b squared, which is minus 31 squared, minus 4 times a, which is 5, times c, which is minus 72, all over 2 times 5, which is 10. And then if I get the plus value first, if I type that in, what do I get? I'll let you know. I get 8. Okay, and then on the flip side, the 9th version, I get minus 1.8. And there we are. So then I have x equals 8 and x equals minus 1.8, or 9/5 minus 9/5. Either or, doesn't really matter. I prefer the decimal in this case. We have to compare these inequalities in a second, so I'm going to keep them. And then same thing with the little graph situation, figure out which one it is. We then have minus 1.8 there and 8 here. If it's bigger than, which it still is, same one as before, we're still looking at the bits above the axes, which is here. So it's going to be kind of two inequalities like it was last time. So x is then less than minus 1.8 and x is greater than 8. Okay, then we need to compare the two of them, right? Because we need to find which set of values will work for x, so will work for all these inequalities, right? Will fit with both of them. So we compare kind of like for like the minus ones with the minus ones, the positive ones with the positive ones. We then get, I'm going to use a different color, I think. My eyes are getting a bit supple with black pen. So we're going to get x is less than minus 7 and x is less than minus 1.8. So anything less than minus 7 is also going to be less than 1.8. 1.8 is bigger than minus 7, right? So if we had like minus 8, that fits both of them. But if we had something like minus 3, that would fit this one, but would not fit this one because minus 3 is not more than minus 7. So therefore, we need to kind of take more priority to this one because this one's the one that's going to cause the most problems. So then that's going to be one of our inequalities. X has to be less than minus 7. Now if we compare the two positive ones, color pen, we then have x is greater than 7 and x is greater than 8. If we compare those two, then this one is the one that also takes priority because not all the things bigger than 7 are also bigger than 8, right? If we have 7.2, that would fit this inequality, but would not fit this one, right? So we want to kind of pick the problem one, which will kind of add the most hindrances because anything bigger than 8 is also going to be bigger than 7, but not everything bigger than 7 is also bigger than 8. Make sense? So that means our inequalities are going to be x is less than minus 7 and x is bigger. Oop, that's not bigger. X is bigger than 8. And that is our final answer. And that is then the end of the paper. There we are. And there we are then, that was Edexcel paper 2 from June 2022, the higher paper. How did you find it? Let me know in the comments how you got on, whether you liked it or not. I think it was a bit easier than paper 1 of this year, kind of significantly easier. And I guess we'll figure out how I found it compared to paper 3 when we do paper 3, I guess. There we are. So that is that. From here, I guess I'll see you later. One more thing actually to plug. I've been posting a lot on TikTok. If you use TikTok, I mean, who doesn't use TikTok, I guess, at this point. I've been posting like things like tips and advice and things like a collection of like hardest questions that I found in papers. So if you fancy a bit of a challenge, my TikTok is full of kind of challenge questions. So feel free to go follow that. I'll put the link in the description down below. But there we are. So then, yeah. Let me know how you felt about the paper. Like, comment, subscribe, all that stuff. And I'll see you then in the next one. So see you then. Bye.